As was promised, this next video here today is all about the identities and how we can use them. We've talked about in the previous video the sine of a plus b and the cosine of a plus b, sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? And noting that one is adding and the other one is subtracting and keeping straight with that. But another identity that should be in the back of your mind always is the good old Pythagorean Theorem, sine squared plus cosine squared equals 1. You might say Pythagorean Theorem. I want you to think about that unit circle one more time. And think about, okay, we have a triangle here, right? And we talked about the fact that this side is the y, or rather the sine, right? And then this side here is the cosine. So if I did the Pythagorean Theorem, I would do cosine squared, right, plus sine squared would equal the radius squared. And what's the radius on the unit circle? 1, and there it is. There's your identity with the Pythagorean Theorem. Point being that all three of these are identities that need to be in your mind. And truth be told, the sine of a plus b and cosine of a plus b is given to you in the reference. However, it's really just buried amidst a bunch of words. So as I said in the previous video, it's better if you just memorize it. And I think it's easy enough, and you'll use it enough that you'll get there. But how does that apply to the sine of 2 theta and the cosine of 2 theta? So let me just show you how to find it. Now, these two identities, they do not give you in the reference. So I want to make sure that we know how to find them given what we already know. So let's just look at the sine of 2 theta and using the sine of a plus b. So I want you to understand, to get 2 theta, do you follow that that is theta plus theta? That would give me 2 theta, right? 1 cookie plus 2. One cookie plus another cookie gives us 2 cookies, right? 1 theta plus another theta gives us 2 theta. So we can actually find this by simply doing the sine of a plus b identity and find what the identity is for sine 2 theta. Let me show you how this works. This would mean you'd have sine theta, cosine theta, plus cosine theta, sine theta. Well, we know with the commutative property of multiplication that we can actually write this as sine theta cosine theta, and we can write this one as sine theta cosine. We can just reverse them and they look exactly right. Doesn't matter. Now, do you see that these are exactly the same? In other words, this equals 2 sine theta cosine theta. So the double angle formula, the sine of 2 theta, is simply 2 sine theta cosine theta. That is another identity. All right, well, what about cosine 2 theta? Is that just as easy? Well, of course, we're going to approach it the same way, and that it's cosine of theta plus theta. And so I would write that as cosine of theta minus sine of theta, sine of theta. Well, how else could I write cosine theta cosine theta? Yep, cosine squared. And sine theta times sine theta would be sine squared theta. So this one looks a little bit different. Cosine squared theta minus sine squared theta. So what did we find out here? We basically found out two more identities. Sine 2 theta equals 2 sine theta cosine theta, and cosine 2 theta actually equals cosine squared theta minus sine squared theta. How does that get used? That means if I have 2 times the same angle, that's what it's going to be. That's how you can find it. It's just a neat little identity. Well, let's see how this also can be applied. Because sometimes, and these are my favorite, I got to be honest, they ask you to solve, basically to prove something. So here they're saying sine 2 theta equals negative cosine theta. And they basically want you to show that it's true, or they want you to show that, you know, what can you find based on this information. And so we just discovered that sine 2 theta is 2 sine theta cosine theta. Okay? And so what we're going to do is use that information to see what we can find out based on that. Sometimes they're going to say, prove that this is true. And other times they're going to say, hey, if this is true, what can we find out? And that's the case here. And even regardless, you're going to approach them the same way. We're going to take sine 2 theta and we're going to replace it. Now, the truth is, whenever you're solving identities, you basically want to get them all as one letter, just like, or all one trig function, excuse me. Just like when you're solving an equation, you want to get them all the same letter, like all x's, so that you can work with just one variable. The same holds true when you're dealing with trig identities or anything else. So what does that mean for me? Well, as I look at this, I'm like, oh, wait, I still got this sine. And I don't have anything that I can replace sine with that makes that cosine. So let's just see if I bring it to the same side, if there's something you can observe to do here. What do you notice? Do you notice the fact that we have cosine in both of these? What if that was an x? If there was an x in both of those, we would immediately think, hey, I could factor that out. So let's just try that. Let's see what happens. If I factor that out, I'm left with 2 sine theta minus 1, and we still got equals 0. Can I solve that? Absolutely. That means I would have cosine theta equals 0, and I have 2 sine theta minus 1 equals 0. So 2 sine theta equals 1. So sine theta equals 1/2. Can I find theta? I hope so. I hope so here. When does cosine equal 0? Well, that would be pi over 2 and 3 pi over 2. And yes, I want you to include all of them from 0 to 2 pi unless it's said otherwise. And when does sine equal 1/2? Sine, of course, equals 1/2 at your pi over 6 angle. So we'd have pi over 6 and 5 pi over 6. Again, notice that I went through 0 to 2 pi in solving those. Well, let's try another one. When you look at this next one, you might think, well, wait a minute, these both have cosine. But the problem that I see with this one here is that what you have is this one says 2 theta, and this one only has 1 theta. So that stinks. We've got to somehow figure that out. So we're going to rewrite this. Let's see. Let's just try this out. Let's write that. We know cosine 2 theta is cosine squared theta minus sine squared theta equals cosine theta, right? All right. Is there something else I can do? Because still I have cosine and I still have sine, right? So how are we going to do that using the information that we know? Because to have all of the, 2 of these cosine and then this guy sticking out, is there something I know that can help me with that? So my hope is you're thinking, wait a minute, there's something with sine squared? Yes. We had the sine squared theta plus cosine squared theta equals 1. Could I solve for sine? In other words, could I subtract that cosine? So I'd have sine squared theta equals 1 minus cosine squared theta. I wonder if that would help. And really, it's just a chance to just really try things out. So let's try that. Let's plug that in here. So now what I've got is cosine squared theta. And then from up in my little cloud here, I've got 1 minus cosine squared theta. And then I've got equals cosine theta. Well, at least I got them all cosine thetas, right? So let's see if we can neaten this up a little bit and work with it. All right, so I've got cosine squared theta minus 1 plus cosine squared theta equals cosine theta. What do you want to do next? Good. At least I hope that's what you said. And so now my hope is that you see this as a factoring question. We bring everything to the same side and factor. Some people like to replace the cosine with an x, but I would caution you about that because a lot of people in turn forget to replace that back and then mess that up. All right, this we know the 1 times 1, right? Signs are different. Bigger one. Well, which one's the bigger one? It would be this one is negative. And so as we multiply, if you want to multiply that out to double check it, certainly you'll find that, hey, she actually knows what she's talking about here. And we're going to solve it. So let's find theta again. Set that equal to 0. All right, so we have 2 cosine theta equals negative 1/2. Sorry, negative 1, and then we divide by the 2. Just got ahead of myself. All right, when does cosine equal 1/2? Well, we know that cosine equals 1/2 at pi over 3, but when is it negative? Not in the first quadrant, but certainly in the second and the third. We don't even need the fourth, so I'm just going to leave it at that. All right, this side, cosine theta equals, or sorry, minus 1 equals 0. So cosine theta equals 1. So when does cosine equal 1? Of course, again, that's at 0 and 2 pi. So all 4 of these would be my answer. 2 pi over 3, 4 pi over 3, 0, and 2 pi. And that's how you find theta. A little tricky and it's quite involved. Sometimes it involves using those identities to help us. And sometimes we can just go right for it, like we did in the previous videos where you saw that happening. So good luck, and we'll be working more on these as classes go on.